The first application of quadratics that we want to look at is the arch or curve of throwing an object up in the air. So we all know gravity exists, right? So the ball is going to go up in the air and then come back down. So in this example, a ball is projected upwards with initial height of 100 feet and an initial velocity of 80 feet per second, and then it comes back down to the ground, right? So they give us that the function that describes the height of the ball is h of t equals negative 60t squared plus 80t plus 100. And they want us to determine how many seconds, so they're looking for the time, which is our t variable, it will take for the ball to hit the ground. So let's go ahead and look at it. So what does it mean to hit the ground? Hit the ground means that your height is going to be 0. So it's going to be flat. If you're thinking of our plane here, so basically you're 100 feet up and you throw the ball and it goes, yay! And it wants to know when it hits the ground at 0. So what is that point when your h is 0? So what we're going to do is just replace h with 0. So it just becomes 0 equals negative 16t squared plus 80t plus 100. Now if we look here, this is just a quadratic equation that's set equal to 0. It's in standard form since it's set equal to 0. So we can go ahead and use our handy dandy quadratic formula to help solve it. So let's write that out. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So your coefficient in front of t squared will be a. I like to just label my variables real quickly. Your coefficient of t is going to be b, and your constant at the end will be c. So if we plug all of these in, you'll have x equals negative b. Since it's a positive, it's going to change into a negative 80. And then b squared, so we're going to have 80 squared minus 4 times a. A is negative 16, and c is 100, all over 2 times a, and a is negative 16. Now, when I've done this before with you, I like to go ahead and just simplify that square root first because, hey, that just makes life easier, right? So we don't have to keep writing everything over and over again. So 80 squared is 6,400. And then this looks like negative 4 times negative 16 times 100 is a positive 6,400 as well. So if we go ahead and add these two together, 12,800, take the square root. It is about 113.14. I'm going to round to like 2 decimal places. And the reason I actually want to find the value of the radical is we're working with a real life number here, and we like to know the actual distance rather than the radical notation. Now, could you have left that in radical notation? Of course. I'd want you to simplify it if possible, and I think you could simplify that one, and then put it back in. So let's go ahead and rewrite our quadratic formula with our new value for that square root. So this is negative 80 plus or minus. Now remember that whole entire square root changed into 113.14. And then 2 times negative 16 is negative 32. And of course, with a quadratic formula, we have to go ahead and break this into 2 different problems. One where we're adding the top and one where we are subtracting. So this would be negative 80 plus 113.14 divided by negative 32, and the other one would be negative 80 minus 113.14 over negative 32. Let's go ahead and simplify these. Now remember, you always want to add or subtract the top first, then divide. So this gives me on top it's negative 1.03. But we can't have a negative time, so bye-bye. That doesn't work. It's not working for the real world, right? Okay, so let's try the bottom one. Negative 80 minus 113.14. Divide that by negative 32. Looks like we get 6.04. And that is going to work because I realized that I should have labeled this as the height. This is your time in seconds. That doesn't make any sense. Okay, yeah. So your height is 0. Yeah. What is your t? Where are you located at your t? Okay, so anyways, so our x or t value would be 6.04. So you were solving for t, right? So in our example, t equals x. So we would label this as seconds. So the ball is going to hit the ground after 6.04 seconds. Give that a try. I know there's one on your homework, so work that out and see if you can come up with that positive solution.